Here we are. This is the second video of GCF and grouping. So we've got some more examples here. We got several we want to do to get finished with this GCF and grouping pretty quickly. So here we go. So we want to factor out the GCF if possible. Now remember, the GCF stands for the greatest common factor, and we want to get the common factor out. We want to rewrite this as a multiplication problem. And make sure we get the greatest common factor out. Okay, so let's start with this first one. Between 8 and 56, again, you have to use your multiplication facts to kind of go through. Now, if you don't know your multiplication fact, I'm going to show you in a couple of slides how to do it if you don't know your multiplication facts. Please feel free to use a multiplication chart, but what's common with 8 and 56 is 8. That is the GCF. And so now I'm going to open up a parentheses because, again, factoring means to rewrite as a multiplication problem. So I'm going to multiply now, or find a number to multiply by, or divide, however you want to look at it. And 8 divided by 8 is 1x, and then 56 divided by 8 is 7. Or you can think of it as 8 times what gave me 56. And so that's it. And it checks. If I multiply that back out, I get the answer. This next one, look at my numbers, 5 and 10. Well, there's a 5 common there. And then I look at my variables. Remember, it's the least power of the variable or the smallest power of your variable. And so for this problem, it's going to be a plain x. And so 5 divided by 5 is 1. And then x to the second divided by x is x. 10 divided by 5 is 2. And x divided by x is 1. And so technically I don't need this 1 right there. I can leave it just like that. Same as the one with the 8. I didn't need that 1. But make sure you know that that's the number that goes there. Because sometimes you need it, sometimes you don't. Alright, so this third one, again, looking at your numbers in your times tables, you should know that 3 is common. And then when you look at your variables, the lowest power, the smallest power of the common variables. They both have x's, and so the smaller one is to plain x. They both have y's, and the smaller one is a plain y. So that's the GCF, and then I'm going to divide and see what's left over. 3 divided by 3 is 1, x divided by x is 1, y squared divided by y is y. Okay, so there were 2, and I took out 1, which leaves me with 1. All right, 18 divide out of 3, or factor out of 3, will leave me with a 6. Factor out 1x, leaves me with an x. Factor out the y, and that's it. So that one's done. Excuse me. Okay, now this one is a trinomial. It's got 3 terms, but they all, looking at those numbers, we got to think a little deeper. There is a 3 common. Now look at the variables. 2 of them have p's, but the other one doesn't. So p is not common to all 3 of them. Excuse me. So now when I do my division, I don't have a p common to all of them, so I'm not taking out the p at all. So there's no common p, so it's not part of the common. All right, now on this other one, the p is the only thing that's common. And so I have 3m minus 5n, just like that. All right. Last one, goodness, last one does not have anything common. It says if possible. When there's nothing common other than 1, because 1 is common to everything, then what we call it is prime. That means we cannot factor it. And that's what that means. Okay, let's look at the next slide. All right, so now what if we don't know the GCF for multiplication? Okay, if we don't know our multiplication facts, we don't know the GCF from multiplication. So we do have a procedure that we can use to find out. Now these numbers right here are pretty large. They are outside of my multiplication facts. And so this is why I'm going to have the procedure. If you, and let me just remind you that everybody's multiplication fact range is different. Some people might need to do this on every single problem because they are not very strong with their multiplication facts, and that is fine. But the idea or the hope is that you can do a lot of problems in your head, and there's only a couple of them where you'll need to use this backup procedure. So here's our backup procedure. We're going to prime factor each one of the numbers. Okay, so I'm going to build a couple little factor trees here. I think 9 goes into 189. I'm going to use my calculator and see if it does. And it does. It's going to be 9 times 21. So I'm going to keep factoring. And so that's the prime factors, 3, 3, 3, and 7. Okay. So now I'm going to go on to 441. And I really don't know. I know 2 won't, but I'm going to try 3. So let's see if 3 works. So 3 is going to work. It'll be 120. Is that right? 3, yes, 127. Okay, so now what about 127? Don't think that's right. I know 3 works, but something's not. Oh, it's 137. My bad. I knew something wasn't right. 137? No, that's not right either. Let's do the division. I don't have a calculator. 147. Goodness gracious. Goodness gracious. All right, here we go. Y'all got to watch me goof up. That's what happens when you don't have a calculator. Okay, so 147. What goes into 147? Let's see if 3 does. Let's see if 3 goes into 147 again. Please use your calculator, because you know what? It's so much better than doing this, but I just don't have one. So that's 3 times 49. Okay, now we're cooking with sauce. Okay, so we got the 3, we got the 3, and this is going to give me a 7 and a 7. There we go. All right, 63. 9 times 7, so that's going to be 3 and a 3 and a 7. All right, step 1, prime factor. Use a calculator to help you out. Okay, step 2, collect the common factors. Okay, so when we go collecting common factors, let's look. I've got a 3 here, a 3 here, and a 3 here. Okay, so they've got a 3 in common. But look, they've got another 3 here, another 3 here, and another 3 here. Okay, and last but not least, keep looking. They've got 1, 7, 1, 7, 1, 7. Is that it? That's it. That's what's common. They each have 2 3s and a 7 in common. They each have 2 3s and a 7. There it is. All right. And so now, when I multiply this together, I get 63. So 63 is the GCF. Whew. All right, so now let's factor this guy. If I take out a 63, oh, wait a minute, what about the x's? Oh, x's are easy. So we've got an x common. All right, so, okay, so take out a 63x. Now I want to show you something. You see this yellow here? That's the GCF. But this right here, that's the leftover. And that's what's going to go in these other spots. So 63 times 3 the leftover, x to the second. 63 times 7, and an x is left over. And then technically there's nothing left over from the third one. There are no leftovers, and so it would be a 1. And so this is the answer for that one. So again, when you have numbers that are much larger than what you can normally do in your own multiplication, use this little procedure over here to get the GCF of the numbers, and it will be helpful to you. Okay, just remember, guys, it's just math. It's just math, y'all. Keep trying.